Here is integrated 3.8-52. So this is just letter C, but the whole problem says Dennis's computer is infected with a virus that will erase information. Oh, it must be Denise. Erase information from her hard drive. It will erase information quickly at first, but as time goes on, the rate at which information is erased will decrease in T minutes after the virus starts erasing information. 5 million times 1/2 raised to the T bytes of information will remain on the hard drive. So I just wrote that down. That is the function that describes the exponential decay of the information that's on the computer. So the question is, when will the hard drive be completely erased? And I thought, oh, well, that's easy. I'll just set it equal to 0 and solve for T. And so I started setting it equal to 0 and solving for T. And then I realized when I got like right about here, I realized, well, I can't take a log or a natural log of 0. I mean, I went ahead and tried it, but you just get an error message because nothing raised to, you can't raise anything to a power and have the answer be 0. So you get an error message here. So then I'm thinking, well, mathematically it's kind of unsolvable. So then I went on the homework help, and it said something like, when is it pretty much technically all erased or something? And so I thought, well, I can't use 0. So I'm going to and I don't know a lot about bytes and computers and things, but I thought maybe I'll set it equal to 1. Okay, so I went ahead, because that solves my problem of taking a natural log or a log, because I need to use the log laws to solve for T, because the T is in the exponent. So I went ahead and just decided to set it equal to 1 to see what happens. So I divided both sides by 5 million, and then I saw that I have T in the exponent. So I just need to use one of the properties of logarithms. So I can either take the natural log or just a log base 10 of both sides. This time I decided to take log base 10. Doesn't matter which one you use. So I logged both sides. That allows me to bring this T down out front. And so I did. And I divided both sides by log of 1/2. And then I just put that into my calculator. And I ended up with about 22 I ended up with like this number, 22.25 something. And we remember that T was minutes. It was in minutes. So I'm going to just say, so if there was only 1 byte left after 22.25 minutes, I'm going to say there's probably 0 bytes left after 23 minutes. Or, I mean, to be safe, I could say 24 minutes. But the answer book says after 23 minutes. So that was an interesting problem.